Hi guys, it's me, Mr. Bertoch. In this video, I'm going to be talking about the Coriolis Effect. The Coriolis effect is a little bit abstract. It is a concept that affects a lot of things around us, like atmospheric currents and ocean currents, as well as, for that matter, airplanes and thermonuclear war. But it's a little bit abstract, and so I'm going to do my best. I will do my bestiest to try and to explain what the Coriolis effect is and how it works and why it does what it does. So, in order to really understand the Coriolis effect, I want you to imagine. Let's go with a missile strike because that's way more fun than an airplane flight. So imagine that we are standing on the North Pole and we have decided that we are going to wage war on the rest of the Earth. And so we launch a missile from the North Pole down to New York. Well, is our missile going to hit New York if we target New York? Because what's going to happen to the Earth? While our missile is in the air and it's traveling along its way towards New York City, what is the Earth going to do during that time? It's going to rotate. Okay. And our missile, which was perfectly targeted to New York, is actually going to end up hitting somewhere, I don't know, Wisconsin or something. Yeah, somewhere further to the west, depending on how long the missile is in the air and how far the Earth is rotated. Okay. So if we are launching a missile and we want to actually hit our target, we have to account for the rotation of the Earth. The same happens, by the way, for airplane flights. When you're driving in a car, you can just follow the road and you get to where you're going because the road is attached to the Earth and your car is running on the road. And so as the Earth rotates, your car rotates with it. But when you're in an airplane, that's not the case. And so as you are flying on your airplane, the Earth is actually rotating underneath the airplane, and they're not connected. The plane and the Earth aren't connected. So the pilot has to account for the rotation of the Earth. Otherwise, they're going to land in the wrong place. Because Chicago, if you're flying to Chicago, it's not, by the time you get there, it's not where it was when you took off. It's moved. And the pilot has to keep moving his target in order to make sure he gets to where Chicago is. And so he or she and the plane and the city can end up at the same place at the same time eventually. That is, in a nutshell, the Coriolis effect, or at least that is what causes the Coriolis effect. So let's talk now about, instead of missiles and planes, let's talk about air molecules and atoms, or water in the ocean does the same thing. But let's talk about air. Air is moving above the Earth, right? And the atmosphere tends to have these things called atmospheric currents, which are simply they're caused by a number of factors, but a big one is the rotation of the Earth, because the Earth is spinning, and that spinning can kind of cause the air above it to also spin, but it's the air isn't attached to the ground. And so as the air is moving, well, what happens is, just like with the missile example, it is deflected. So to the west or to the right is in the northern hemisphere. Okay, as the Earth rotates, the air, the molecules in the air are deflected as a result of the Coriolis effect, and they arc. Instead of going straight, at least from the perspective of the ground, they arc. And the air behind them arcs, and the air around them arcs. And the result is that you start to get this sort of spinning. It's not enough in just a regular atmospheric current to actually spin. It just arcs. But when you get a storm with a lot of energy, let's say you get a low pressure, and in another video I talk about low and high pressures and how they create wind. But let's suppose I have a low pressure. Without the Coriolis effect, the wind is going to come just straight into a low pressure. So here's my low pressure, and the wind is just going to come right into it from every direction straight in. But because of the Coriolis effect and that deflection, that arching, the wind comes in and it starts to arch, and it creates sort of a spinning, not a perfect spinning, but sort of arching into the low pressure. In the northern hemisphere, wind comes into a low pressure counterclockwise. And this is because of the mixture of the tendency for air to flow inward towards low pressure, the Coriolis effect, and also friction. In the southern hemisphere, it moves clockwise. So it's counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Wind is also moving out of a high pressure in an arch because of the Coriolis effect. So again, imagine the Coriolis effect is imagine that you are on an airplane and you are traveling in a straight line, but the Earth is moving, and the result is from the ground, it looks like you were actually curving. If I drew your path on a map, it would be, even though you flew in a straight line, your path from the ground, perspective of the ground, would look like a curve, because the Earth curved, or the Earth rotated. And so even though you went in a straight line, the movement of the Earth made you look like you were curving, and the air does the same thing, and all of that curvy air causes storms, low pressures, causes the wind to begin to rotate, such as, for example, in a hurricane. In a hurricane, we get this big, massive low pressure where the wind is circulating around the low pressure. And that is the Coriolis effect, and that is what the effect it has on the weather, on the wind. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos, and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.